Hello students, we are starting last assignment 7.5 today, and there are 5 questions and mainly 2 topics. Equations for tank circuit, that is LC Oscillator Circuit, and transformer. We will deal with this assignment in 2 different video sessions. In first one, in this video, we'll talk about first 2 questions of this assignment. It is 21 and 22. 21 is obtain expression for instantaneous current, instantaneous charge and frequency of oscillation for LC circuit. Next one is for LC oscillator circuit, discuss variation in energy stored in inductor and capacitor as function of time. The other 3 questions we'll see in next video. So let us start with 21 and 22. We know that in tank circuit we have a charge capacitor connected in parallel with an inductor. So here is a capacitor with capacitance C and an inductor with inductance L. We assume that initial charge on the capacitor is Q0 when time is say T0. Okay. So as the two are in parallel, we should be able to say that voltage across inductor is equal to voltage across capacitor. So L di by dt can be compared with Q by C. Okay, and we know that I is equal to dq by dt. So I should be able to write here minus dq by dt. Why minus sign? Because we know that initially if there is any charge, suppose there are charges deposited on capacitor when it is connected, the moment you connect with inductor, the charge will start flowing in the circuit and hence the charge is decreasing. This dq is negative, and so we consider this negative sign here. Now if I rearrange the terms, sorry, I forgot one thing. I is replaced with dq by dt, and we already have one d by dt. So this is the equation. Now, if I rearrange the terms, I arrive at d2q by dt square is equal to q by LC with negative sign. And then d2q by dt square plus q by LC is 0. So now, if you recall, in our standard oscillation chapter, we had one second order differential equation for oscillation, which says that omega square is angular frequency of oscillation. So if I compare these two, look at these two terms, then I can say that the frequency of this circuit, angular frequency of this circuit, if it is denoted with omega 0, then omega 0 square is 1 by LC, or you may say that omega 0 is 1 by root LC. Okay, what is this omega? This is the angular frequency with which charge will oscillate. Okay, and if you take this to be 2 pi f0, then f0, that is frequency of oscillation, can be given as 1 by 2 pi root LC. Okay, so that is frequency of oscillation. Now, how do I obtain equation of charge or current? So again, this comparison itself gives us that answer. We know that for second order differential equation, that is for d2y by dt square plus omega square y is equal to 0, the solution is y is equal to a sine omega t plus phi. So if I have d2q by dt square plus q by LC is equal to 0, solution should be q is equal to qm sine omega t plus phi. So in this case, A is maximum displacement, Y is displacement at time t, A is maximum displacement. Similarly, Qm is maximum charge, Q is charge at time t. Instantaneous charge, you may say, what is Q? Instantaneous charge. So for this equation, for second order differential equation of charge, I can say that the solution has to be Q is equal to Qm sine omega t plus phi. And what is Qm and what is phi? So we may say that those two are constants. And let me note it down. Qm sine omega t plus phi. When we are writing, we don't know what is Qm and phi. So we say that Qm and phi are constant. Okay. Now, if I take when time t is t0, we can say that q is equal to qm sine, no, let me first differentiate so that we can write two equations together. So if I differentiate equation 3 on both sides, I get dq by dt is equal to qm being constant, no need to differentiate, d by dt of sine omega t plus phi, and then left side is current at time t, and the right side will give me qm omega 0 cos omega t plus phi. Let this be fourth equation. So now if I take time t to be t0, initial time if you take, then let it be 0 only, then this t will be 0, then equation of q becomes q is equal to qm sine phi, and in equation of current, if I take t to be 0, initially there is no current, so left side is 0. So 0 is equal to qm cos phi. Sorry, omega 0 I forgot. So qm omega 0 cos phi. So now I'll not be solving this, but if you solve this too, if you take ratio, sine by cos will give you 10, and from that you realize that phi is pi by 2, and qm is q0, and that is very true. What is the maximum value of charge? Maximum value of charge is the one which we have initially on capacitor. So qm, maximum charge, has to be q0, because initially, see our statement, we assume that initial charge is q0. So it validates that maximum charge cannot be more than q0, and phase difference is pi by 2. So with this, our equation of charge and current now becomes q is equal to q0. Look at this. Instead of this qm, now I write q0, and instead of pi, what I write? Pi by 2. So q0 sine omega t plus pi by 2. Sine omega t plus pi by 2 makes it cos omega t. Okay, so that is our fifth equation, equation of charge in LC oscillator circuit. And similarly, in the equation of current, in this equation, if I replace this q m with q0 and phi with pi by 2, what do I get? So then I have I is equal to q0 omega 0 cos omega t plus pi by 2. Now cos omega t plus pi by 2 means you are going into second quadrant where cos is negative, and hence the equation is minus q0 omega 0 sine omega t. let this be sixth equation. So equation 5 and equation 6 are the equations of instantaneous charge and instantaneous current in case of LC oscillator circuit. And second equation is equation for frequency of oscillation of charge. How fast this charge will oscillate between the inductor and capacitor. That we can determine by second equation. So that is all about question 21. Look at the question. Obtain the expression for instantaneous current, instantaneous charge and frequency of oscillation. Now let us move to second one. For LC oscillator circuit, describe a variation in energy of inductor and capacitor. So now if I write expression for energy of capacitor, it is given as half q square by c. Okay, and then in case of inductor, it is half L I square. We know that capacitor stores its energy in form of electric field, and inductor stores its energy in form of magnetic field. Okay, so let me write here U B. B indicates magnetic field. So now I substitute Q value. So 1 by 2 Q0 square cos square omega t plus 5 by 2, and this equation becomes half L I square, that is Q0 square omega 0 square sine omega t, and no phi. Sorry, here also I should not mention phi because we are considering cos only. Let me confirm it. See, equation of charge is q0 cos, equation of current is q0 omega 0 sine, so that is what I have considered here, and I square is taken, so no negative sign. So this is the energy of the charge capacitor. Now instead of this L, this L, I am making one change. We know that omega 0 square is 1 by LC, or else you can say that L is equal to 1 by omega 0 square C. Okay, so I'm making that change, and with that change I have omega 0 square C, Q0 square omega 0 square sine omega t. Now we have equation of energy of inductor, we have equation of energy of capacitor, and so we can talk about total energy. So U is equal to UE, energy of inductor, plus energy of capacitor. You can swap it, and then 1 half Q square by C plus 1 half Li square. Substituting these values, what I get is half Q0 square by C cos square omega t plus half. Now look at this, omega 0 square will be cancelled out, and we have again Q0 square by C sine, this should be square, sine square omega t. So simplifying on the common terms, we have sine square omega t plus cos square omega t, which will be 1, and then the energy U is half Q square by C, and that is the initial energy of charge capacitor. So this is the expression for the energy in LC oscillator circuit, and these two equations indicate that at any given point of time, energy is distributed between capacitor and inductor, and when capacitor is decreasing its energy, inductor is storing energy. When inductor is giving energy, capacitor stores. So that is all about expression for frequency, expression for charge, current, and energy in case of LC oscillator circuit. Thank you.